in that cut paper. So I'll just dive into the mathematical aspect of production function, and I really hope you can be able to crack this question. So this question normally comes in this form. The production function of a business is given as Q is equals to 100 L is to power 0.2, K is to power 0.8. So you're given a function Q is equals to 100, L is to power 0.2, K is to power 0.8. Then you're told the cost of labor is 50 and capital is 75 shillings. So the cost of labor is represented by L. So L, the cost of labor is 50 and capital is 75 shillings. The firm can spend only 5,000 shillings. So in case you get a question like this, because it's always there, you will even see it in the cut papers and past papers. You're given a production function, and then you're given the cost of labor, and you're also given the capital, and then you're told that the firm can spend only 5,000 shillings. Then you're told to find the value of L, the value of K, and the value of Q. So in such a case, the first thing that you do, you're going to say Q is equals to 100 L is to power 0.2 is to K is to power 0.8. So this is the production function. So you just copy it. Then from there you go to the second part. The second part is called L is equals to objective function plus this symbol here, inakaa y ambayo imeinama. So mathematically, what do we call this symbol? Yes? Mu. Another term? Is alpha? Any other term? Ati gani hiyo? Gamma? Okay. Another term? The last one? Okay, so I don't know which one we will go with. This symbol, let's call it, someone has said mu. Is it mu or sigma? So let's call it mu, this symbol. Then you have constraint, into bracket constraint. So you just write objective function plus this symbol, then into bracket constraint. So the objective function in this case is the production function. Q is equals to 100, L is to power 0.2, K is to power 0.8. So this is our objective function. Our constraint function, you take now the cost of labor that you have been given. Here our cost of labor is 50. So that means that our constraint will be 50L. 50L because this is the cost of labor and we have L now. So 50L plus capital. Our capital is 75. So here our constraint function will be 75k. K is a symbol of capital. So 50L plus 75k is equals to 5,000, which is our constraint. Any question up to there? Any question or clarification? Okay, there is no question. Yes? Carry on. Yes? Where specifically? Okay, the production function is what we are calling it the objective function, Joey. And then the cost of labor is 50, so here we have 50L. Capital is 75, so we have 50L plus 75K is equals to, the firm can only spend 5,000. So this one we are calling it constraint. In short, we are just naming our function. We have the objective function and the constraint function. If or true. Okay, that's the function of constraint. Yes. Yeah, I think that way it's better. Okay, we can proceed. So when you have the constraint function, sasa hapa hesabu ndo imeanza kuingia sasa. This was introduction. This is what you do. You make the constraint function to be equal to 0. You equate the constraint function, ama the constraint, we are calling it constraint. You equate it equal to 0. So what do you do? So if you have 5,000 here, you see this plus 75k, you take it to the other side, inakuwa minus 75k plus 50L. Take it to the other side, it becomes minus 50L. So our new constraint function itakuwa 5,000 minus 50L minus 75k is equals to 0. Ni kubeba tu, na beba hii, take it to the other side, becomes a minus. Beba hii tena, take it to the other side, inakuwa minus 75k, alafu sasa unasema is equals to 0. Then from there now we have this equation. So this is called the Lagrangian. So L is equals to, our objective function ni hii 100, L is to power 0.2, K is to power 0.8, plus we come and write our symbol, ndo hiyo hapo, into bracket constraint, our new constraint function hii. So we are going to say 5000 minus 50L minus 75K. That is what you do. So I'm thinking of something up to where we are. We should be doing a question. Let me look for a question that relates to this, so that you can be listening and working it. You're working it out. It seems that we'll just proceed because I'm not getting the past paper, but I think I'll share it after the lesson. So we can proceed. 100 L is to power 0.2, K is to power 0.8 plus mu into bracket 5000 minus 50L minus 75K. So here I've just tried to distinguish between this L and this L. This L has a different name. It's called Lagrangian function. This L is the labor. So I've written M so that I can be able to distinguish this L and this L. So M is equals to 100 L, 0.2, K is to power 0.8 plus, here we are opening the brackets, 5000 mu minus 50L mu minus 75K mu. So here we are just opening the brackets. From there we can now go to what is called the first order derivative. For the first order derivative, we are going to start. Oh, there's a hand raised. Yes, any question? Okay, I've said I'm introducing M so that I can be able to distinguish this L and this L. So that is why I've written M. You can see this equation is L and here the equation is starting with M. Okay. Okay. So we can proceed. We go to first order derivative. In first order derivative, we are making L the subject of the formula. Make L the subject of the formula. So it means that you are going to differentiate. When you hear the term derivative, it means differentiation. I think we did calculus last semester. So we derive. So we differentiate. So in short, we are, I hope you can see my screen. Okay. So we are going to say change in M over change in L is equals to differentiating. So we are starting with making L the subject of the formula. If you can remember what you used to do in differentiation and you want to differentiate this part. So where you have L, that is where we are differentiating. So you come and say 0.2 times 100. As you can see here, 0.2 times 100. Then L, the same L, 0.2 minus 1. So we normally multiply 0.2 times 100 and 0.2 minus 1. Then from there, after differentiating L, K remains constant. So K is power 0.8, K is power 0.8 as well. And then from there, we are going to say minus 50 mu. Minus 50 mu. So we are going to ignore this 5000 mu and we also ignore this. And when we come, because you're only differentiating L, we are going to say minus 50 mu. so you ignore the L as well. So in the constraint function, we are ignoring the 5000 mu minus, we ignore the L, then we ignore the minus 75k mu as well, and then we say is equals to 0. That is our equation number 1. I want us to go to equation number 2 and equation number 3, and then if you have a question you can ask. Let's proceed. Here we were making L the subject of the formula. Here we are now going to make K the subject of the formula. So we proceed, changing M the same way we had done, changing M over changing L. So changing M over changing K is equals to, now we are differentiating K. So where you see K, we are going to say 0.8 times 100, 0.8 minus 1. So that means you're going to say 0.8 times 100, L is to power 0.2, L still remains the same, K 0.8 minus 1, and then we ignore the 5000 mu minus, we also ignore the 50 L mu minus 75k. So where you have K is what we maintain, minus 75 mu, because we are differentiating the K. So what you just need to know, we ignore the 5000 mu, we're also going to ignore minus 50 L mu, but where you can see K is where you differentiate, and ignore the K and say 75 mu is equals to 0. That becomes our equation number 2. Equation number 3, we make mu the subject of the formula, and this one is easier. Yes, just a minute, I finish the third here, and then you can ask. So make mu the subject of the formula, changing M over changing mu is equals to, so here you're going to write changing mu is equals to now the constraint function. So this third equation is the constraint function. This one is our equation number 3, and those are our 3 equations. So any question, you can proceed. Oh, that's this 100 is at the beginning of the equation, so that's why we are using it. 0.8 times 100, or 0.2 times 100, according to the rules of differentiation. Yes. Yes, this 100, you're still going to use it here. Yes. Okay. Okay, thank you for that. Any other question? Okay, so after that sasa hesabu inaendelea kukua tamu. So we are going to make mu subject of equation number 1 and equation number 2. We are going to make mu the subject of equation number 1 and equation number 2. How are we going to do that? We are going to start from equation number 1. So you solve it. 0.2 times 100 is what? 20, yes. So it will be 20 to power L. Sorry, 20L. 0.2 minus 1. Yes, 0.8, negative 0.8. Then k is to power 0.8, then minus 50 sigma. That is equation number 1. So 20L is to power negative 0.8, k is to power 0.8 minus 50 sigma is equals to 0. So that is equation number 1. The only thing we have done ni kusolve tu equation. Unasema 0.2 times 120. 20L 0.2 minus 1 gives you negative 0.8. K is to power 0.8 minus 50 sigma is equals to 0. 50 mu. So from there, so after solving equation number 1, you take this negative 50 mu, you take it to the other side. So what do you have? 20L is to power negative 0.8, k is to power 0.8 is equals to 50 mu. Umeona what you have done? E minus tumeileta hii side. So ikikuja hii side itakuwa plus. So we have 50 mu. Then you divide both sides by 50. Divide both sides by 50. 50 ita cancel out na 50. 20 divided by 50. 0 na 0. So we will have 2. L is to power negative 0.8. K is to power 0.8 divided by 5. 2 divided by 5 is 0.4. L is to power negative 0.8. K is to power 0.8. The last part, so that you can ask a question. Mu is equals to, mathematically, when you have L is to power negative 0.8, it is the same as saying 0.4 K is to power 0.8 over L is to power 0.8. So here L unatoa the negative, alafu unasema you put division L is to power 0.8. So you can just check it out. I give you a minute, uangalie hesabu, uniambie ni wapi hujaelewa. If you have a question similar to this, kindly send it to me so that we can practice it. I'm trying to, I don't know where my questions are. Yes, Andrew? Fine, thank you. Okay. Mm-hmm. 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 We use what? Sijakuelewa bado. This one. Mm-hmm. 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 Mm. Mm-hmm. 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 Instead of the K. Nimekupata vizuri sana. Yes, any other question, then I'll answer you. Yeah, sure. Okay, that is good. So we can proceed to part 2 or equation number 2. So we solve this. So 0.8 times 100 will be 80. So we say 80 L is to power 0.2, K is to power 0.8 minus 1 minus 75 mu is equals to 0. So you just come here. So this is now our equation number 2. 80 L is to power 0.2, K is to power negative 0.2 minus 75 mu is equals to 0. So this minus, you take it to the other side, you will have 75 mu. Divide both sides by 75. Then you will say 80 divided by 75. Mu is equals to 1.067. L is to power 0.2. This one. Then K is to power minus 0.2. So we have said that when you have a negative, this is what you are going to use for division. That is according to mathematics. So where you have a negative, so we are going to say 1.067 L is to power 0.2 divided by K is to power 0.2. Any question? So as we proceed, I would like you to write a question. You can write this question so that we can use it. Write it down. The production formula of a business is given as, the production formula of a business or the production function of a business is given as Q. Q is equals to 200 L, L power 0.7. So we have Q is equals to, so instead of 100, write 200. L is to power 0.7. K is to power 0.3. L is to power 0.7. K is to power 0.3. Then you write the cost of labor is 500. So here we are writing the cost of labor is 500. L is to power 0.7, K is to power 0.3. So cost of labor 500, capital is 800. Then the firm can spend 20,000 Kenya shillings, 20,000. Then you write, formulate the problem. That is question number 1. Formulate the problem for output maximization. Number 2, determine the optimal units of labor and capital. Formulate the problem for output maximization. Determine the optimal units of labor and capital. So I want us to finish this one so that you can start working on that. So after you reach here, we were here. So you're going to take this mu 0.4k is to power 0.8 over L is to power 0.8. You write it equals to the second mu 1.067 L is to power 0.2 over K is to power 0.2. Cross multiply. So it will be 0.4k power 0.8 times k power 0.2 equals to, so tumemultiply hivi tukaziweka pamoja, equals to 1.067 L is to power 0.2 L is to power 0.8. In short, tumeweka hizi pamoja, this and this together. So mathematically, when you have k is to power 0.8 and k is to power 0.2 together, you are allowed to add. So k powers zikifuatana, na here there is no symbol, so you're going to add the powers. 0.8 plus 0.2 inakupatia 1, so we'll have 0.4k is to power 1, of which it is the same as saying 0.4k is equals to L pia zimefuatana, add the powers. 0.2 plus 0.8 is 1, so hapa tutasema 1.067 L. Then you want to find the value of k. Divide both sides by 0.4. So we will have our k, so this one will cancel out. K is equals to 2.67 L. That is the value of k. Kuna swali hapo pa ku cross multiply? So this question, I know it's not easy, but you really have to practice it. So from there we substitute k in equation number 3. So in equation number 3, this one, we already have k. So we substitute it, so it will be 5,000 minus 50L minus 75 into bracket k. So our k is 2.67 L. So we'll have 5,000 minus 50L minus 75 into bracket 2.67 L equals to 0. So here we can say minus 50L minus 200.25 L. So who can tell me what is the value of L? Value of L. So here we just subtract minus 50 minus 200.25 itakuwa minus 200.25 L peleka the other side, ikwe plus 19.98. So hapa ni kutumia tu calculator. Minus 50L minus 200.25L. So ukitumia calculator itakupatia minus 250.25. Peleka the other side. Yes, 19.98. So this one here, I made a mistake. It should be 19.98, not 1.998. So then the value of K. So if you have 2.67 and L is 19.98, 2.67 times 19.98 inakupa ngapi? Yes, 53.3. So you just multiply. So what will be the value of Q? Kama ni Q is equals to 100. So change this, should be 19.98 power 0.2. Alafu hapa ni 53.3 ama 0.4 power 0.8. What is the value of Q? So you just solve in mathematically. 100 times ama into bracket 19.98 power 0.2. Unafanya tu calculator. 19.98 power iko hapo kwa calculator 0.2. Unaandika value chini. Naandika 100. 53.3 power 0.8 unaandika value. What are you getting as the value of Q? Yes? Inastahili kwa something close to this. Ni venye decimal hapa ndio iko misplaced. $43.83.56. Okay. So this question, unless you do it, ndio utaweza kuijua vizuri. So I want us to start from here. Nimewape swali. And I can see time is much gone. So but nataka tufike mahali na hii swali. So anyone who does not have that question, Q is equals to 200, L is to power 0.7, K is to power 0.3, cost of labor ni 500, capital ni 800, the firm can spend 20,000. Nani ana hiyo swali? So we all have it. So very fast we can start it. The next 5 minutes tuko tumefika mahali. So you can write the production function. Q is equals to, who can tell us what are we going to write? Q is equals to what? Yes. Exactly. So tunaandika pamoja. Q is equals to 200 L is to power 0.7, K is to power 0.3. Haya, twende next. Next tunaandika nini? Yes? What have you written? Mm-hmm. 20,000 as the constraint. Very good. So yeah, amesha name objective function ni hiyo, constraint ni hiyo. Very correct. Haya, let's go to the next part. Who can tell us what are we going to write? Okay, wewe umeenda hadi huku. Tuko hapa. But anyway, it's okay. So for those ones who are writing hapa, wenye wako hapa, you are one step ahead of us. Wenye wako hapa, what have you written? Yes, carry on. Kama imepoteza. Yes, can you hear me? Oh, sorry. So because of time, I would like you to try that question. I've sent you the notes, and I know I'll upload the video in some few minutes on Telegram so that you can be able to access it. So this question, unless you practice it, that's the only way out. So you can send in your workings, then I'll be able to mark, and I'm also supposed to mark the FM questions. I think I'll mark them tomorrow. I'm a bit free tomorrow. So, and in case of anything, the video lecture will be available. You can always rewind and forward until you get the consent. So thank you very much for your time. Let's meet tomorrow for management accounting. Tomorrow I'll be available at 7:30. Thank you so much. I don't want to keep you for long hours, eh? Yes? Okay, if there's no question, we are free to leave. Thank you so much for your time, and I wish you the very best. Thank you.